Yes. Yes, Tama, we are in.
Yeah, hello everyone. Welcome to this webinar. I can see a lot of you jumping in the meeting room, so really happy to welcome you today. So we have the chance today to welcome Monica Lucas from Rembol and also Nazanin Rezaogazi from Halter in Switzerland. You will be hosted by the Energy Institute. I'm part of the Energy Institute as professor. So I will spend a few minutes to do the introduction of this webinar. And I'm glad to be here with Dr. Zohaib Batra, moderator of the Q&A in the end of the webinar. So maybe a few words about the schedule of the webinar itself. So after my introduction, we've got some technical issues. So I think Monica will start the webinar by introducing her work as Rembol, as structural engineer. How do they deal with the embedded carbon of buildings? And then we had the chance to benefit from the speech of Nazanin about life cycle assessments at early stage of design. Each presentation will last 15 minutes sharp, please. So it's quite short, but it would be wonderful to have around 20 minutes at the end of the webinar to let the floor to different questions, Q&A moderated by Zohaib. And I will conclude with a closing session. Few words about of institutions. So we are part of the University of Applied Science of Western Switzerland, and more specifically, part of the School of Engineering and Architecture in Fribourg. We are 10 research institutes, and we belong to the Energy Research Institute, which is focusing on applied research in energy systems. And with my team, we are more specifically focusing on buildings and neighborhoods working on energy efficiency and environmental impact life cycle assessment methodologies. We've got different research projects, among which we can cite the SWICE project, on which we're working on energy sufficiency in the built environment, for instance. But we also have other projects on the contribution of biosourced materials, for instance, in the decarbonization of the built environment. You can have a chance to have a look to the different projects we're working on and publications on a website, which is called buildinglowcarbon.com. And we would be really happy to see you on the website, sharing different research materials with you. So as you know, we face different challenges. We have multiple goals to reach climate goals and climate neutrality as of 2050. And the built environment is a significant contributor. We do a lot of research to try to improve tools and methods to support the whole value chain to move into this climate transition. And what we observed during the last couple of months and years is that we need to better link and to bridge the community between practitioners and researchers. There is a lack of awareness about the embedded carbon issue into the built environment. And also policymakers and regulatory bodies are now looking to regulate the sector. So we really need to build a community around life cycle assessment of buildings and embedded carbon emissions. So that's why we decided to launch this webinar series in the context of the future EPBD, so the Energy Performance Building Directives that will make mandatory life cycle assessment of buildings in 2028. So it's only now in almost 3 years. More specifically, in the Swiss context, now we have a new norm that sets some targets for the embedded carbon of buildings, which is followed in Europe by different countries that already regulate this sector. So this is why we are really glad to welcome all of you today in this context of momentum of working on embedded carbon of buildings, sharing between research and practice. And we are very happy to welcome today two researchers and practitioners on that field in the place here of this webinar with Monica and Nathaniel. I will leave the floor to Zohaib for the instructions of the webinar, and I wish you a pleasant webinar and see you in the end.
Thank you, Tama, for your introduction, and thank you everyone for joining us today. I just have some brief instructions for you. That would be basically when we start our sessions with the speakers, please use the chat box functionality in your Teams to pop in your question and the name of the speaker whom you want to ask the question with. Since our technical error is resolved, we have Nazneen will be presenting first, and you can use their QR codes to connect with them on LinkedIn. Your mics and camera will remain disabled. So off to the start with Nazneen. Nazneen, you may take the control of the presentation.
Yes, thanks, Toma and Zuhai, for your introduction. Next slide. So a little bit, I want to say hello to everyone joining this webinar. My name is Nazanin Rezai-Obazi. I'm a PhD in Architecture and Environment from EPFL Energy Institute, a host institution of the series of webinars. And I want to emphasize that I arranged the content of this webinar based on research that I did previously in 2019. And on the menu today, I brought 3 interesting topics for you. First, I will start with the significance and challenges of at the early stages of design. That I move to the concept of carbon budgets and show you with some examples how it actually and
Sorry, Nazneen, to interrupt. Your mic is breaking. Can you increase the volume or bring your mic
yeah.
up?
Is it better?
Yes, thank you.
Perfect. And then after the carbon budget, I move to my favorite part of this presentation, which is introducing you the explorative LCA, the methodology I developed during my PhD to make informed decisions, balancing daylight and life cycle CO2 emissions. So we need to first understand why is it so important to perform a reliable life cycle assessment at the earliest stages of design and how the topic is relevant to the world. So I want to start with the classic introduction in the LCA realm, which is the share of building sector in global CO2 emissions. Among all industries, construction and operation of buildings is the biggest emitter of CO2 out there among all other industries and is alone responsible around 40% of global CO2 emissions. And at the same time, the research and practice prove that this industry has a great potential for carbon mitigation, actually, if the main players and building stakeholders like architects, engineers, policymakers, and so on make the right decisions and, more importantly, at the right time. The research shows that around an impressive 70% of building CO2 emissions are locked in early decisions. For instance, decisions regarding the dimensions of superstructure, the facade configuration, the use of renewable energies, and so on. However, life cycle assessments come too late to the design process to actually guide those early decisions. So to elaborate a bit more on this concept, I want to borrow from a simple yet powerful statement in businesses and finances, which says, if you don't measure, you do not improve. And I think in the context of life cycle assessment, it requires an important adverb, which is early. And this concept has been very well depicted in McLemo's curve. Some of you may already know it. McLemo curve says that architects, engineers, and basically all the players in building design procedure concentrate their efforts on later stages of design, typically technical and developed design. These efforts consist of energy simulations, comfort simulations, life cycle assessment, and so on. However, there's a need for a shift to concentrate all these efforts to the earlier stages of design and to be more specific at the schematic design phase, which is typically between week 1 and week 12 of the design procedure, in order to influence the design for good at the lowest cost. While it is evidence that we need to perform life cycle assessment as early as possible, it comes with a bunch of challenges and hurdles. If I want to mm, put all these challenges in just one statement, I would say there is a fundamental mismatch between life cycle assessment and the context of a design process. And to be more specific, I articulated these challenges or the main challenges in 5 points. First of all, we need a high resolution of details. We need to know information regarding the choice of material and components, dimensions of them, the configuration of facade, interior and exterior elements, HVAC sizing, and so on. However, many of these information are missing or very blurry at those early days. Besides, we need to consider multitude of design parameters that actually affect lifecycle assessment results, which is based on the existing research. It can vary between 14 to sometimes even 30 design variables, which makes lifecycle assessment super complex, not only at earlier stages of design, but also in later stages of design. Lifecycle assessment is inherently a time-consuming task. It can take, based on the existing surveys, up to 34 hours, even with using computer softwares. And we can see in practice that for larger-scale complex projects, it's even more. And this is why lifecycle assessment is typically and relatively an expensive task, both in terms of consultancy services and the required tools. Based on the anecdotal data that I gathered here and there, the cost of environmental and sustainability consultancy, including lifecycle assessment, can take up to 15% of total consultancy services. And this number is even growing due to global push for regulatory compliance. And finally, we not only need to perform life cycle assessment once, but also more than once. And based on the existing research, we have to repeat life cycle assessment 3 times at those early stages of design, because architects and engineers prefer to work with alternatives, typically 3 alternatives and sometimes even more. So these are the main challenges of performing life cycle assessment at the earliest stages of design, but let's imagine we can overcome all these challenges. You may ask yourself how. You have to wait until the last part of my presentation. And let's imagine we can have reliable LCA outcomes at the schematic design. So here comes a very important question. Is the design good enough to pass on design development or not? Or in other words, is the design in line with global carbon budget or not? So here the concept of carbon budgets and benchmarking become very important, and the mantra or the statement change in my head, like if you don't benchmark early, you do not improve. So I want to move to the next topic, which is the carbon budget at the earliest stages of design. I know that our audience in this webinar are international, but I want to give a little bit of context in Switzerland. There are some efforts in norms and research in order to formulate some kind of carbon budgets. The first instance can be found in 2000 Watt Society, introduced in 1998, which tries to limit each individual's environmental footprint to only 2000 watts, from which 1500 watt must be from renewable resources. 20 years later, Swiss Society of Architects and Engineers published CA 2040, which recommends limit values for construction and operation of building, which is recommended to be around 12 kilograms CO2 equal per square meter per year. And then these budgets got then updated and refined in the recent CR 390, which was published just a couple of months ago, and which recommends progressively declining carbon budgets for each and every year from now until 2050 for different building types. If we look at the scale of these carbon budgets in this existing research and norms, we can see that all the efforts are focused on formulating carbon budgets at the level of whole building. These building scale carbon budgets are useful and valuable benchmarks, which often guide high-level decisions, such as whether to build or not to build at all a building. the compactness, the size of building, whether to apply for Minergie for SMS goals or not. However, these budgets are not sufficiently detailed to guide decisions regarding the choice of material and components, or in other words, these building scale carbon budgets are not sufficiently detailed to guide day-to-day tasks of architects and engineers. So if architects and engineers have these detailed carbon budgets, they are able to make detailed these decisions and focus on making the best choice for every single component of building without having to deal with the complexity of the building as a whole at once. However, at the time that I did my research, such carbon budget at the level of components was missing. So I used the method of target cascading in order to cascade or in fact decompose the building scale carbon budgets at the level of each and every component of building. So I decomposed in fact the building into 21 constituent components and defined carbon budget for each and every single component of building. And then I did not only calculated the carbon budgets for the time being, but also from now until 2050. So for instance, in the graph in the left side, you can see the carbon budgets at the level of components for the 6 component of facade from now until 2050. And let's say you have a building that is going to be constructed in 2030, you can already start working on making the choices and dimensions for the facade of this building using specific carbon budgets for every component of the facade. And finally, the explorative LCA and the methodology that I developed during my PhD. If I want to put it very simply, in very simple words, that what is explorative LCA, I would say it is basically making the knowledge database of thousands of design alternatives and couple it with a design exploration interface, which makes it possible to navigate through these design alternatives. You may ask yourself, what is a knowledge database of design alternatives? It is basically design alternatives beam models, including the geometric and semantic information of each design alternative together with their performances, which was in my case and in my research, I focused on life cycle carbon emissions and daylight sufficiency and try to find a balance between them. I also created my knowledge database around 1 million design alternatives for 3 residential building archetypes, but the methodology remains true for any type of building like office, retails, and so on. So basically, the main value or the main, in fact, idea of explorative LCA is to automate the workflow. So it allows for generating thousands of design alternatives based on predefined parameters. For your information, these predefined parameters were sieved through sensitivity analysis in order to make sure that the parameters are among the most influential ones. And finally, I had the chance to evaluate my methodology through lab usability test in the frame of a project called Light Budget Project, a 3-year long project that I managed previously. And my explorative methodology was, along with some limitations, was evaluated as efficient, reliable, informative, and easy to use. If you're interested in knowing more about explorative LCA, please feel free to scan the QR code, download my latest publication published in the Journal of Building and Environment, and give me feedback. Feel free to send me also LinkedIn messages. I will definitely read them and enjoy your comments. And thank you so much for your attention and looking forward to the next talk.
Thank you very much, Nazanin. It was very insightful to see your presentation on early stages design. I'm sure all that audience who is attending right now would be having many questions. So I would invite them to post questions in the chat so that I can ask them during the Q&A. And now we move forward with the next presentation by Ms. Monica Lukash. Yes, Monica, over to you.
Yeah, there we go. So, hi everyone. My name is Monica Lucas, and I work at Rumble, based in Oslo, in Norway. And thank you so much for inviting me. I wanted to start a little bit by saying just a few words about the company I work for, which is Rumble is a Danish company, and we work all over the world. Also, I think in Switzerland, even though that we are not as big as in the north of Europe or in the US, but we work basically with architecture, engineering, and consultancy services in transport, water, industry, finance, technology, and buildings, which is the field that I work for. I'm a structural engineer as a background, but I work as a lead for sustainability and sustainable buildings, from Norway. So I wanted to start with this question, which maybe some might be thinking that this is the trick, or like it shouldn't be answered, or we should say yes. But I wanted to ask this, like, do we want to reduce CO2 emissions, or why are we talking about this today? And the reason why I'm asking is because actually our like industry, or like we represented here today somehow, is not focusing on reducing the CO2 emissions, but just on reporting the CO2 emissions. And in fact, I agree very much with everything that Nazanin said. So I thought it was super interesting because, in fact, for calculating the CO2 emissions, you don't need to know anything about the project. So you don't need to be a designer or a structural engineer. And the only thing that you need to know is probably where is located the building, the number of floors, and then you go into a software, put in some quantities, and there you go. And in many cases, you can even print the results and use it for some certification. So to me, the answer to this question is yes, but of course, if we want to reduce the CO2 emissions, then we need to actually focus on the phases where we can actually reduce the CO2 emissions, and not by just calculating the carbon at the end of any project phase. So how to achieve this, or how do we reduce the carbon? I would like to mention that 70% of the carbon emissions are released before the building is ever used. And more than 60% of these comes from the load-bearing structures. So it seems completely crucial to focus that controlling the CO2 emissions in these phases is crucial for reducing the overall carbon of the projects. So I've thought very much about this, especially the past 3 years, when all regulations in different countries came into place, and we are more and more pushed to think about carbon. And to me, it felt pretty basic that this is the formula that we are looking at. We need to have more structural engineers and more designers doing carbon assessment in order to reduce the CO2 emissions. And when I was talking about 70% of the emission released before the building is ever used, I was referring to what is called the product stage, which is the phases A1 to A3 in the table. This is a representation of whole LCA analysis. And the first phases, or everything that is in green, is what happened before the construction stage, meaning what we actually can do when we are designing, or when we are taking decisions, and while we are forming the whole project. So how do we do these carbon calculations today? As a simplified method, this is basically what you need to do. You need to know where it's located. You need to select if it's a wall or slab, and then you select maybe some material. if you know the product you selected. Otherwise, you just assume, and then you put in the quantities. Once again, you don't need to know anything about the project. This is pretty much what any software will ask you. And there are several softwares that will allow you to do this to everyone. And then the question is, who is doing these calculations today? It's actually sustainable engineers or environmental consultants. This, I know that it's changing, and this is like part of my daily work. So it has been changing continuously, but the fact is that it's sustainability consultants, the ones in charge of this. And if we look back once again to the parameters and what we need to know for doing any carbon calculation, these actually parameters that the designers decide while they are dimensioning, or when they are calculating things with other disciplines, deciding how the project is going to be formed together with the architect. So basically, all of the parameters that any designer works with and that decides in the early phases. So how can we have any kind of impact or change in the results if we don't involve the colleagues deciding material, products, geometry, and quantities for all the building parts? It's impossible. Then we will be ending into just a pure calculation and not in any reduction. So the formula that I showed before, to me, it kind of changed very much, and the more than I thought about it. And I started to think that we don't need to just think that the structural engineers or designers will lead to less carbon, but that we actually need to include all designers into carbon assessment, and not only the ones that knows Grasshopper or any software, but absolutely all, because this should be an assessment and not just a calculation. And when we are talking about sustainability, this is actually crucial, because it's very much what Nazanin showed in one of her slides. It has to be done early, or it has to be during the decision-taking process and not at the end. And it's true that usually we do LCA calculations or calculations for carbon several times, but it's always at the end of the project phases. So it can be at the end of an early phase, at the end of a detail phase, and then at the very end of the project when you have to send the documentation to the authorities or according to some standards, which is different from country to country. So I thought that how will I include absolutely all the structural engineers and designers in Norway doing carbon assessment? And I put together all my colleagues, and this is their representation. And I started to think like, okay, let's try to do carbon assessment with the information and the tools and everything that we have to do, that we have today. The first thing is that some of my colleagues here already disappeared because we needed a software that cost money, which also Nazanin mentioned earlier. It will create the need to have a special license, and probably will cost more than many departments want to, because they know that some sustainability consultants can take this part. We are just designers. Then I continue, and many other of my colleagues just disappear also from my overview because of this specific knowledge that is connected to sustainability. Suddenly, all the designers need to know about carbon factors, EPDs, GWP, GWP, A1 to A3, units, cubic meter, square meters, kilos, generic values, which databases do I use, and whatnot. So suddenly many, and especially the ones that are a bit less motivated to work with sustainability, will just not be interested in doing that. Then I was losing again. many of my colleagues into my purpose of having absolutely everyone, including or doing carbon assessment. And I continue using the usually software that we have for carbon assessment. And many of my colleagues also disappear because it's very difficult to update these calculations, or it's time consuming. And the thing is that in any project, we are changing things all the time. So we work with the model. Usually we model absolutely everything in 3D. In our way, we even model the reinforcement. And this is something that it changes every time. Whenever the architects or the electrical engineers or the ventilation changes, then we model things differently. And suddenly it comes some opening here and there, and then everything changes in the model. So it has to be like flexible. It has to be like livable. And this is something that we don't have if with the current softwares for doing carbon analysis. Then I lost even more of my colleagues because there are many parameters that you have to actually add manually. And with that, accuracy also is gone. And this is something that, especially for engineers, is like super important. We are all very keen to understand absolutely every number, and we need to know where the value is coming from, why if I change something in my model is not being represented, or I'm not getting the results correctly into the carbon assessments and so on. So and also, of course, since you have to put in many factors manually, is time consuming once again, which is something that is not very interesting for designers. Then I even lost more of my colleagues by the time that we're looking at, the carbon assessment is not connected to our models. It's not connected to Revit or Tekla or the programs that we usually work with when we're while designing. So during designing, and the programs that we use continuously and actively with the rest of the disciplines during the project, which means that if it's not integrated into the programs that we use for 3D modeling, then it's like an extra administration, and it's something that's it creates like it's almost like a punishment for some of the designers, because somehow the belief is that this is just some numbers that I have to put together in order to report, and not something that will contribute to actually reduce the emissions, because it will be easy to calculate, it's connected to your models and so on. And then the last is that I almost lost of my colleagues, which thought that this was a waste of time, a time that they don't have. So I was pretty much like alone into this while using any of the existing softwares. And I suddenly realized that the structural engineers and designers are not the target of the existing tools. And they are not supposed to be the users of the existing tools for carbon calculation, because these tools are made for reporting and not for reducing. So then it was very clear to me that we needed a product that will solve this problem. So we need a new solution for an existing problem. And the product or the tool, it will help as many engineers as possible for doing carbon assessment. So that's why a couple of years ago, or 1 year and a half, I started, or we, me together with some colleagues, we started SCORE, which is a tool that we created in-house that stands for Structured CO2 Report. And the only goal with this is to include absolutely every single engineer and designer into carbon assessment. And it has changed the way that we design and the way of we communicate with clients. So that was a very quick presentation of how a score works or looks like. But basically it's an add-in in Revit that allows us to continuously know where is the carbon coming from? Where should I put my time? Should I look at the walls? What happens if I change this? What happens if I do that? What if I look at these two alternatives? And it's connected to IFC models, and it's connected also to that database, which means that you don't need to have a super deep knowledge into sustainability. If you're a designer, you just need to consider it and take it into account into your decisions. So it's a decision-making tool. And it's not for reporting, even though that you, of course, get a calculation and you can just send it for an LCA analysis afterwards if you want to. But the goal is to actually reduce. So thinking very much about the formula that I showed you before, including all the structural engineers will lead to more carbon reduction. We had in mind what we needed. It had to be for free, had to be easy to use, had to give accurate results, easy to update and track changes, the possibility to use with others, not only the ones used in Revit, and definitely the most important is that it will give value, so that the structure engineers and designers don't feel that, well, it's not that don't feel, but that they will include this as a scope of work, because this is just not an administration thing, I like to say. It's just not, just need to report a number, but that it will actually lead to reductions. And of course, it's a learning process. We know much more now about sustainability and carbon than 10 or 5 years ago, or even 3. So we are growing into another kind of engineer that traditionally has not been focused on these kind of things. So what happened is that actually we included something else to the formula, because we have been already working with the tools and with the clients differently, and it has led to reduction of the cost, because of course when you are reducing material it will cost less, and if as we get involved earlier in the projects, it will lead to some decisions at early stages, which is usually cheaper than when you come with changes afterwards in the project. So I would like to just finish with a little bit like call for action, or what I like to call, at least a call for action, which is that if we want to reduce the carbon emissions in the buildings that we design, we need to stop focusing on just reporting, because we are wasting time, and we are already in 2025, and it's time for like real solutions, time to develop tools that actually we can use while designing and not at the end of the project phases. So I hope that I motivated people to think a little bit differently, and that's it.
Thank you, Monica. It was wonderful to see your presentation and also your experiences with investigating stepwise with structural and design engineers and their needs, especially the score tools. Very interesting. So I think I would give the opportunity to the audience once again to post some of the questions if they have for you and for Nazanin that we can ask in the Q&A session. So I invite both of you to the Q&A session now, which is for the next 15 minutes. So audience, please be active. We have to make best use of this time. So moving on to the Q&A, we have a few questions for both of you. First, I would like to start with Monica, because the presentation was very, very fresh, I would say. How do you handle the technical building details, like structural safety and fire resistance that come up in LCA, and how does it impact the reliability of results, despite the point that it does not need extensive knowledge of LCA? This is a question asked by one of the audience members.
Yeah, I see, Jasmine. Yeah, thanks so much for bringing this up. It's actually not an easy question to answer because it depends on the level of detail that we are looking at. So in some early phases, we are just focused on probably defining a structural system that works because we are in that early stage where the layout, it has to be defined, and maybe we don't know anything about what will happen later. In some other cases, then we go into more a higher level of detail, and then we have to think more about the I see like fire regulations, or if you need to have some requirements. Then it's a matter of balance. Like it's like designing, it's the whole like designing process. You have to create the point that using, like for example, Score or the tool that I mentioned, is it's meant to be used by like professionals. It has to be. It cannot be used just as a button that you click and give you a result. It's meant to be used by designers that knows what works. So you know that if you have this slab with the columns there and the walls there, it cannot be probably 8 meters long because it's not gonna work statically. And in the same way is with the fire requirements. You have to know some knowledge about, okay, I have some steel columns in my building that I know they has to be insulated. So then I know that I have to think about that when defining maybe the profiles, or I know that I have to talk to somebody to try to push them to maybe paint them instead of choosing one kind of profile or another in order to reduce the CO2 emissions. So I think it depends. Hope I'm answering the question, but it depends. But the level of detail that you are looking at, and also, of course, you always have to have some technical knowledge about what you're using, and that's why my point is that it cannot be done by just maybe a sustainability consultant, because that person cannot have the responsibility for those decisions, and those decisions should be made during the design phase.
Thank you, Monica. I think your answer can be summarized is that you need a team to really decide onto the viable options that have to match the needs of LCA, the structural requirements, and even performance requirements in terms of energy. So it's a cross-disciplinary team that should decide it in early stages to find the viable options. Thank you very much. So I would move on to the next question for Nazneen. This is a question which has been asked from Professor Thama Uzerme. So I will ask you first, Nazneen, can you elaborate a bit more on your current practices of LCA in your companies, and what are you doing? What is the main driver? At which frequency and what stages are you really working with the LCA, and what are the main barriers in the adoption of in your own companies?
So yes, in our company, Halter, I think life cycle assessment is a common practice. We do it actually. It is very promising that we do it quite early. And but if I want to talk a bit more general, I think the main barrier of using life cycle assessment at the earlier stages of design is to change the mindsets. It is most of all difficult to convince practitioners that there is a need to think to bring life cycle assessment as early as possible and make it a decision-making tool, not an afterthought. So I think, yeah, generally, one of the barriers that I see is data management, because we have different equipes involved in design process. For instance, digital building and planning, the building economics, the architects, engineers, and so on. And in order to kind of harmonize the data that we use, we need to shift to model-based lifecycle assessment, which is a shift from kind of Excel spreadsheet style of life cycle assessment into a model-based, where all the quantities and information, both geometric and semantic information of building components and material, come from a B model. And I think this is a very important step to be taken. that's also very important for practitioners to make sure that whatever the tool or methodology of LCA it must have a great interoperability with the tools that they use at the moment. Because if you have a workflow or tool that is a standalone and doesn't have a good operability and is somehow a Swiss Army knife that does everything alone together, I think practitioners start to resist using such tools. So it is important to make sure that the methodologies and the flow of data is right for the practitioners and allows them to use their existing tools and workflows and softwares without having to use something completely new.
Thanks, Nazanin, for your reflections. Indeed, it aligns this methodology of LCA or adoption of LCA in practice with something when BIM was being adopted in the early I would say 2000s, when it became popular slowly and into the workflows of people now. Every practitioner knows at least what it is and how it's being used to the benefit of collaboration. And I hope changing the mindset is the key, what you just answered. So taking on to that, I would also like to extend this question to Monica. You said that given the call to action to create tools for structural engineers and designers and incorporate carbon assessment into their work, what do you think are the biggest barriers preventing the widespread adoption of these tools? And how can industry overcome them?
Yeah, I think I don't think we don't have any other choice, I would say, because regulations are coming and are coming very fast and in most of the countries. So what for 4 years ago, it was just a very light requirement of reporting at the end of a project. It's now maybe a limit in some countries that you have to achieve. And for achieving that, I mean, the numbers that we have for achieving that, they are also changing. And we all, I think most of the countries in Europe, in the world, we are all in the Paris Agreement, where we are going to decrease already in 2030 by 50% emissions and so on. So we don't have any other choice, because right now we are doing LCA analysis in all projects, but soon, probably already next year, we have to achieve a certain limit. And for doing that, we need to involve the designers. Otherwise, there is no way to achieve those limits, and there is no way to learn how are we going to decrease those numbers, which is also something that comes very, very fast.
Thanks, Monica. I think an extension to your question, to your answer is also there's a question in the chat that what's the adoption rate of your score tool at Rumble and how do you intend to distribute it?
So we are using SCORE in every project, in every phase, and all the structural engineers in Rumble Norway right now. SCORE is also implemented in Sweden and Denmark, and we are going to implement it in Finland. But the implementation process for these 3 countries is taking a little bit, well, we are on that in 2025. So for example, just to give numbers so that you realize, since January, we had 75 projects that has submitted results into SCORE, which has created also a database, which we didn't have at the beginning, but now it's something that we can actually use for benchmarking. So we know what are the levels, in which projects we are actually having maybe higher levels than we should, and who did that, and maybe why, and so on. So the power of having a tool that people is using is giving us more than we thought at the beginning.
Thanks, Monica. That's a good answer. So moving on to Nazanin, there's another question in the chat about a researcher focusing on LCA, and they would like to ask, from your experience, which areas or topic do you think are still underexplored and are promising for future studies in LCA?
Actually, there are so many things to explore. I guess one of the most interesting areas for practitioners is the beam-based lifecycle assessment, and there are actually very good uh, research basis for this that people or researchers can build on it. The other area that I see a little bit less touched is the ability to work with EPD databases, because the research shows that sometimes there is a huge deviation between the standardized um, um, material databases, which are at the level of national with the EPD databases. So that would be also an interesting point to discover a bit more. As I said in the previous question, the question of interoperability, I think, is still, it has been the topic of research for many years, but I think the answers are not still very convincing. So I think these topics are the most important and interesting ones at the moment.
Thanks, Nazreen. I would say, since we are approaching towards the end, I have one last question to ask to you. Your presentation highlighted that the challenges of LC at early stage design as mismatch of design process, multiple iterations, and need for high resolution data. There are so many parameters to assess in the beginning. How can you think these challenges can be addressed in practice, especially for smaller firms which have smaller projects to work with LCA?
Yes, so if I want to answer from my perspective, I would say changing the mindset and being more open into new methodologies of doing life cycle assessment, like parametric life cycle assessment, or like what I worked previously, explorative life cycle assessment. This is, I think, a perfect method for dealing with especially multitudes of design parameters. And there are also some simplified methods and tools to use, but the problem with them is that the simplified methods are sometimes a bit misleading. So what I suggest is to, instead of looking just at one, for instance, previous building or similar project and try to learn from it, gather a large database of such projects and use statistical learning methods and machine learning methods in order to make a collective knowledge based on a large database of existing tools and models.
Thanks,
Yeah.
Nazim. I think maybe we can take a few more seconds for the last question in the chat about your switch from research to practice. You're at the best place to see the gap between the two. And in your experience, how this gap can be filled? Shortly, you could answer that.
So I
Nazim.
guess, yeah.
Yes.
So to fill the gap, actually, I think we need more and more pilot projects to test the methodologies and the workflows that has been previously developed in research. There are so many good researchers at EPFL, at ETH, Chalmers, and so on, but we need to test them actually in real environment. In my experience, I use lab usability test, but we need to move a bit further, be a bit more bold and brave, and test it in real environment and collect feedback and consistently work on developing and elaborating such new methodologies and workflows. And yeah, I think that the main point would be to invest on pilot projects.
Thanks. Thanks, Nazim, for your answer. I really thank both of the speakers for this Q&A. It was really insightful for the audience. So I would like now invite Professor Tama Yüzelme to give the closing of the webinar and any comments.
Yeah, thank you again, both of you, and also thank you, Zahid, for the idea of this webinar and for moderating the Q&A. So it has been really a pleasure to listening about your experience in research and practice. This is just the start of a series of webinars. We're going to have 3 other webinars this year. So we record the webinar and it will be shared by emails. So the ones that couldn't attend today will receive it. If you also want to spread the webinar to your colleagues, you will have the possibility to do so. So feel free to really share the recording. It will also be available on our website, buildinglowcarbon.com. And the 3 upcoming webinars are about to be released. So if you want to be in, just say hi in the chat now, and we will circle back to you to send you the link to attend to the next webinars. So next webinar also will be in French because more anchored to the Swiss context and to also make the link to local practitioners, but we will use live captions to translate in Teams. Again, thank you, everyone. We are just in time, just 1 minute left, so that's perfect timing. Thank you, all of you, and see you soon for the next webinar.
Thank you, everyone.
Thank you.
Thank you so
Bye-bye.
much.
Bye. Ciao.
Bye,
Bye.
Nadine. Bye, Monica.
Bye.